Okay, now the goal here is to use the given information to construct these others. And we've kind of done something like this in the past, where we took the given information, this created the triangle to model the problem, got the ratio, the trig function ratio we needed, and then decided if it was positive or negative based upon where the angle is located. So this first angle, alpha, or if you want to just layer it A, it's in the first quadrant. And the second angle, beta, or if you want to just call it angle B, is in the second quadrant. So I like to draw a lot of pictures because for me, it's easier on my head. So that's what I would do. That way I can, oh, okay, first quadrant, second quadrant, without thinking. So the first problem, they told us that the sine at the angle A was 1/3. So I'm going to model the problem using a triangle. So for the angle A, I'm going to use this triangle. They said the sine was 1/3, so opposite over hypotenuse is 1/3. Now the second problem, the second part, alpha B, I'm sorry, angle B, not alpha B. Yeah. They told us that the ratio was 1/4. Okay, so again, I'm going to use a triangle to model this problem. So here's the triangle based upon the angle B. The sine is 1/4, so opposite over hypotenuse is 1/4. And now once we get the other side, we can get all the trig ratios we want without having to do too much math. And so the Pythagorean theorem, now, at this point, I'm just going to write what you would have gotten. Right, so notice you would have done 3 squared minus 1 squared and then take the square root. 4 squared minus 1 squared and then take the square root. So, okay, so if we wanted to now find the cosines, okay, well, the cosine at A, and let's say the cosine at B. All right, well, adjacent over hypotenuse, we can see, and so √8/3, and it's positive because this is in the first quadrant. Okay, cosine B, we can see visually, adjacent over hypotenuse would be √15/4, and it's in the second quadrant, so this is negative. Now, if you want, you could use the Pythagorean identity. Right? And then you take the square root, right? So then you can just put 1/3 or 1/4 there, but that's going to be a little bit more work than necessary. This is much more intuitive, much quicker. But I'm just pointing that out. Nothing wrong with that. Okay, so now I'm not going to do all of them just because I think, just getting the idea is relevant. So let's say we did the cosine A minus B. And we wanted to figure out what's the cosine A minus B going to be. Okay, well, first, if we want to figure out what the cosine A minus B, using what we were given in the initial problem, this 2 sine ratios, we've now constructed a way to get sines and cosines. And so once we do the difference formula, map that out, we'll be able to replace the sines and cosines based upon the A and B. All right, so again, the mnemonic, cosine, opposite, and then the sine. Okay, so the cosines first. So cosine A, cosine B. And then the opposite, so since that's minus, we'll put a plus. And now we'll do the sines. Sine A, sine B. All right, now we just got to replace these 4 things, and we already have a model to do that. Okay, so the cosine of A would be √8/3. The cosine of B would be √15/4. cosine A should be positive. The cosine B should be negative because it's in the second quadrant. So I'll just put a little negative right there. Okay, now the other two. So the sine A, well, we were given the sines initially, but you can still 1 over 3, 1 over 4. All right, so then it's just a matter of multiplying that out. So this would become and probably what you would want to do is change the root 8 here. Factor out a 4. So, you know, square root of 4 times the square root of 2. And then you could go ahead now, 2 times 15. So probably the simplest way you could do this problem in the end. And then okay, now we'll do the tangent. Okay, so if we want to do the tangents, then in the tangent sum or the tangent difference, I guess we'll do the tangent sum formula since that's what's right here. Then we're going to need to get tangents first. Okay, so the tangent here, well, vertical over horizontal, right? Opposite over adjacent. So the tangent of A is going to be 1 over root 8. What about over here? Well, again, vertical over horizontal, opposite over adjacent. The tangent of B would be 1 over root 15. Okay, now we decide, is it positive or negative? Well, first quadrant, they're all positive. Second quadrant, the tangents are negative, so this should be negative. All right, I'm going to erase all this. The issue here mainly is how to simplify once we set this up. Okay, so constructing tangent A plus B from the original given information. From the original given information, we already determined the two tangents we need. All right, so if it's plus here, it's plus on top. And then on bottom, it's going to be 1 minus 2 multiplied. Now, I wouldn't rationalize the two tangents first. And there's a reason why I suggest that. I'll point that out right here. So I'm going to leave the two tangents unrationalized. And since this is second one's negative, I'm just going to write minus. And then on the bottom, we get 1 minus. Now, since this is going to be minus a negative, I'll do the same thing. I'll just go ahead and erase that minus and put a plus there. Now, this is why I suggested not rationalizing, because right now, if you can multiply top and bottom to get rid of the denominators a lot easier. So you can just multiply top and bottom by root 8, root 15. And then that'll give you, cancel the root 8 over here, you have root 15. Cancel root 15 over there, you have root 8. And then on the bottom, you get the 1 times, which is going to be the same thing, root 8 over root 15. And then here, they'll be eliminated plus 1. And now if you have to rationalize, this will be much more manageable. Of course, that's still going to be yucky because those are big numbers. But rationalizing this, the next step, would be that. And I'm just going to point that out. And again, notice I didn't multiply the 8 to the 15 because, you know, if you multiply root 8 root 15 to root 15, it becomes 15 times root 8. If you multiply root 8 root 15 to root 8, it becomes 8 times root 15. That's why I left it not multiplied.